sharing with us the cool stuff they do, so the whole community can level up together. Thank you. So first, let me invite Manish to share about how he powers up a super app with data science. Manish is head of data science at Go-Jek, and take it away, Manish.
Thanks, Eugene. One correction, I don't power the whole data science team does, and I think we have a pretty stellar team who would be presenting later on, so yeah. Cool. Let me start off with, why we call this a super app, right? I mean, you keep hearing about apps, but now we are calling Go-Jek as a super app. And one testimony to the fact is the journey that it has been through, how it started off as a, small bike hailing company, bike sharing company, and then how it expanded its use cases, right? So I'll just take you through some of the journey around that, how we actually use machine learning in the team, and how we power some of the features that you see and end up using. So as a company, I think the mission is to use technology for a social mission, right? That's at the heart of what we do. The social mission is to actually provide means of livelihood for a lot of Indonesians. That's how it started. And now as we grow across Southeast Asia, we carry the same mission, right? And something to note here is how we have unlocked the potential of this informal sector. That's mind-blowing, and I'll share some numbers about it later. So that's at the heart of what Go-Jek does. We also have GoPay. The aim over there is financial inclusivity, how we can provide payment gateways, how we can actually become an alternative to what a bank account is for many Indonesians, right? Where the bank account is not that popular, and it almost replaces what an account is for people. So as I said, at the heart of it is driver well-being, right? And that's what the social enterprise is about. So in terms of impact, right? If you look at what we have been able to achieve in Indonesia, is we have been able to drive the average income of that country up by providing or unlocking these opportunities for people. Alongside that, we have given the customers an aha experience, and that's what we strive for. We have we provide earnings to close to 2 million plus drivers who use the platform almost every day. What started off as a bike sharing company, as I said, exploded into a bunch of other use cases. So, there's a very limited set being represented here. So we have over 18 plus services, but just to give you a few examples, so you can order food, you can order groceries, you can order beverages, you can get your car repaired, you can get your house cleaned, you can also get a massage, and if that was not enough, you can also get a makeup done at your home itself. So what all this means is that we have seen phenomenal growth over the past 3 years. 125 million plus bookings per month, a scale of 6,600x growth in a matter of 3 years is not many companies can claim. And to the extent that every second person in Indonesia actually uses Go-Jek, right? And that means the scale that we serve them for, we have to maintain a lot of reliability across the systems. We have to power them with a lot of machine learning and a lot of data science, how we can actually automate and make all this possible even with a very lean setup. So one thing about Go-Jek, if you see, is that it's a very efficient in terms of what the people produce. So almost the entire tech is maintained by around 250 engineers, and that's, again, if you look at it from a per person's impact perspective, we always take pride in saying every person literally contributes around 500,000 trips in a month. So how we actually use machine learning in some of these applications and various services. So here I am giving one example for a single service. So as you open the app, right, you will have a bunch of services which are customized based on your location, your hour of the day, and we do some pre-ranking logic over there to surface the needs that you have so that it's easy for you to discover the services. I don't think many companies can say that they have this kind of a challenge where it's hard to find out what service to do. So that's a pretty unique problem that we try and solve. Once you get to that and then you enter an actual service, you are now undergoing this anxiety of choice because you have almost 1 million dishes to choose from. Here I'm giving an example of GoFood while you are trying to order food. So we use shuffle cards. These are some infinitely scrollable lists where we pre-populate them based on your ordering history, right? And we use a bunch of recommendation engines for merchants and surfacing those relevant content to you. And relevance is at the heart of when we try to, customize the feed. Now, once you have selected your merchant and you have found a merchant, now comes the next part where you need to actually price it right, and you have to consider your supply, your demand, a bunch of other features, and then you have to basically, what we call in the terminology of ride sharing as surge, to have the right price set to that. Of course, there are a lot of bad actors as well. Many people try and game the system, abuse the system, so we have to keep those checks and balances in place as well, which is where we try and detect fraud, make out who are the real users, who are the fake ones, and just cut down the usage in general, and that's the risk scoring part. Then comes the part of allocation, which drivers to allocate that job to so that that booking gets completed, and we want to maximize, because that really comes in the way of an experience, right? A good experience. So we want to maximize that as well. Now, once that is done and the delivery partner has been assigned, we move on to, if there is a bad experience, someone might raise a ticket, and we want to reduce the time to resolution of a ticket, right? So we use some automation over there and do pre-filtering and prioritization logic. After that, once the order is completed, then we want to see how we can make the user come again and again so that it actually becomes a habit, and also try and see how we can predict the LTV, because that's pretty business critical, right? How we spend, how we retain people. So that's an example of one service. If you look at the entire spectrum of data science problems at Go-Jek, it's pretty huge. So since it starts off with a matchmaking company, so there is a supply and demand side to everything that we do. So to just illustrate the fact that marketplace is that central team which tries and manage or make it very efficient how supply and demand interact with each other. So we try to put them together and try to balance those forces. The supply side of workstream works more on supply positioning, identifying some fraudulent activities, and preventing churn. The marketplace team, you would hear from them later on in the talk, works on allocation or dispatch models, what should be the surge, how we can enhance some of the experience. They also monitor health of a city terms. Then you look at the demand side, and we try and use a lot of automation to allocate vouchers, how we can be very efficient in our spend, and also try to understand the persona of our customers. So unless we understand why people use Go-Jek, we will never be able to give them the best experience, and in the spirit of personalization as well, that's a huge input, right? Then we also try and reduce churn on the demand side. So now, transport is the one big focus area because that's a gateway to a lot of other services, so that's the primary focus. So if you look at food, it's always about personalization, it's about discovery, it's about ranking items. So those are some of the efforts over there. We also have a huge team dedicated purely on payment, where they try and look at how we can increase the offline payment space, how we can reduce some of the fraudulent activities which happen because there is a lot of abuse which happens on promos. And we also are into the lending business, so there is some credit risk models which also we try and build. Apart from that, we have some specific, pretty niche work streams which are around fraud. How do we, like every other service has a possibility of encountering fraud, and fraudsters keep changing their strategies, so we have to really be on the eye for them. And how we can automate, how we can use AI or ML to surface those. Maps is another initiative where we try and use a lot of open source maps that we have and try to get the right routing, get the right ETAs, because all of those are pretty important for a reliable experience, right? We have some streams working on ops. Platform is a big one. Here we have a pool of machine learning engineers whose single aim is to make data scientists efficient and effective, and how they can reduce all the, how they can make the life of a data scientist easier. So there is a lot of systems they build. XP is also an effort towards having an experimentation platform, because behind every product feature rollout, we have a ton of experiments which happen, and if those experiments are not carefully ironed out, they are not properly measured, there is always a risk of making a bad decision. So that's the efforts towards experimentation platform. Topic speakers for the day. So first we'll have, if you remember, the marketplace team. So we'll have Jawad and Peter talk about how we match our riders and drivers. Second, we have Zilay. So she comes from the platform team. So how we build complex machine learning flows, and she will talk a bit more about that. We have Jaeger, who's here for the growth and well-being of the team and how we can better organize ourselves. And that's a topic which is probably not touched upon a lot, is how we can avoid burnout in data science and how we can be more efficient. I leave you with one video. Syafri, where are you? Okay, so Syafri leads the team in Jakarta. Sorry, I forgot to mention. So we have a team in Singapore as well, where primarily most of the data scientists are. But then we also have a team in Jakarta and in Bangalore. Syafri leads the Jakarta side of things, and here's a team video. So just I want to leave off with this, and yeah, here you'll see probably the team culture and probably some familiar faces in the crowd.
You're supposed to dance now.
He has a microphone, but thinks he. Oh, there's also
So here is a classic example of how you need to learn in real life situations and then adapt to it. So I think while the guys fix up the video, so what we really value in this team is, we work across 3 pillars of how we can grow, how we can be more efficient, and how we can basically drive the user experience to an aha moment. Right? So these are the 3 guiding pillars for us, and we really take care of the driver's livelihood here. I mean, the well-being of drivers is really at the core of every decision that's taken. So that's something fascinating. I mean, as I said, the company is a social enterprise. That's how it started. So that's something pretty unique given, all the other players in this space. So that's something which keeps me very motivated.
Hi, my name is Shafri. I'm a VP of Data Science at Go-Jek. I've always been fascinated by math as a subject, and probably one of the reasons is that my father is a high school math teacher, So in a way, math has been in my blood. I remember when I was in 4th grade in elementary school, and I stumbled upon arithmetic sequence problems, where the teacher asked us to solve twice differentiable arithmetic sequence. And being very stubborn, I tried to extend the problem into 4 times differentiable arithmetic sequence instead. So I asked for my father for help. However, instead of helping me to solve it, he posed me a math book on the table. And that book was actually for university students, and he wanted me to find the solution myself. Maybe he meant it as a joke, but I actually spent hours reading the book, and I got fascinated by a combination of ideas in the book. That was when my interest in math started to grow. So another memorable story about the math Olympiad in high school was when I was hospitalized right before the Southeast Asian Math Olympiad. So I got dengue fever, and the doctor put an IV on my right hand. But somehow I still practiced by solving math problem with left hand in the hospital. So I feel like when I put my mind on something, I'll just do whatever it takes to get it. So just like when I wanted to pursue a master degree in math overseas, I put my mind to it, and I even imagined myself sitting on the grass and soaking the summer vibes in Europe. So I tried to apply it to a lot of different scholarships. And fortunately, I had the chance to go to the University of Twente because I got a scholarship from the Dutch Ministry of Education. My major was applied mathematics with specialization in financial engineering. After I graduated, I stayed in the Netherlands for 9 years. I worked there as a quant, which is a rather niche profession that rigorously applies mathematics and statistics in solving financial problems. Although in its purest form, quant is actually data science before the term data science has even known, and it is applied specifically for financial problems. After working as a quant for a while, I came to realize that the impact I made when I was a quant can't extend much further beyond the company I work for. I just want to do more. I want to work to benefit a lot of other people. That was when I found out about a big digital movement going on in Indonesia on a very big scale. I still remember the night when I was browsing on LinkedIn. That was when I came across a video of Nadim explaining Go-Jek's impact and social mission. It started as a 5-minute video, and I ended up bashing my keyboard for 3 hours, researching about data science in Indonesia. That night actually triggered me to go back to Indonesia. Then I actually went back to Indonesia and eventually joined Go-Jek. I'm interested in data science because it combines 3 of my favorite subjects, math, statistics, and engineering, in order to solve real problems. And these are problems that actually matter for people. I think Go-Jek has a unique position where we have a vast amount of data, and as a data scientist, we want to turn that raw ingredients into a Michelin-starred menu. At Go-Jek, we use data science to unlock actionable insights and enrich our product features from the data. Currently, we have 3 data science hubs at Go-Jek, of which Singapore and Jakarta being the biggest one. Our data scientists come from different nationalities and backgrounds. And one thing that I really like about having these versatile people at Go-Jek is that we all come together and try to solve meaningful problems at scale, be that on a whiteboard, through Slack, or during coffee breaks. The problem-solving traits are embodied within us. So being a data scientist might have not always been easy, but we have a lot of helpful colleagues to reach out. If you want to try at Go-Jek, I think you need to be data-driven, a good problem solver, creative, and technically rigorous. And you need to be able to play hard as well. Hi, mate.
Okay, let's give a hand to Syafri. I think he went through a lot of pain to make this video. Cool. So yeah, I mean, as you see, the spectrum of problems, the engineering challenges, the vast amount of data that we need to process, there is a lot of opportunity to drive impact, and I think that's a big motivator for the whole team. So yeah, I mean, no need to put it in a subtle manner, but yeah, we are looking for talent, we are looking for rock stars. Please feel free to reach out to any of us if you want to know more. with that, I think I'll pass over to Peter and Jawad, who will talk about how we match our riders and drivers.
Hello everyone, I'm Jawad. Thanks Manish for the great introduction and talk. For this presentation, I've been working in data science marketplace team for about 1.5 years, and primarily my focus was on solving allocation and pricing related problems. So without further ado, let's just continue with the session. So the agenda of this discussion would be, we'd first start with an introduction to Go-Jek marketplace team and the different components involved in Go-Jek marketplace team. After that, we'll look at the formulation of matchmaking problem at Go-Jek. After which, we'll be talking about the allocation system. Rank or driver ranking was a first generation allocation / matchmaking system, and Jaeger is the new and improved version of rank. Peter will be talking about rank later in the session. So, what is Go-Jek Marketplace? You know that Go-Jek has at least 18 plus product offerings in Indonesia, but at its heart, Go-Jek is a marketplace startup. The entire objective is to match service providers with service seekers, and how we do this is core to our business and critical to our operational efficiency. So let's look at an example of a customer making a go-car booking, and I'll walk you through the entire process of how Go-Jek Marketplace has different activities in the entire state of the transition pipeline. So Marketplace starts working even before you try to book an app. The drivers are shown information regarding the high supply areas, so they can use this information to strategically position themselves for better allocation opportunities. And once the customer launches the app and enters the pickup and destination location, the price estimate is computed and shown to the customer. It not only depends on the road distance between the starting and the destination location, it also takes into consideration the dynamic real world volatile demand supply situations in the marketplace, and then adjust your price accordingly for better operational efficiency. Now, once the customer decides to make a go-car booking, the Go-Jek Marketplace allocation system looks for closest drivers surrounding the customer, and then among those list of drivers tries to choose the best driver for the specific job. So once the driver has accepted his booking, Marketplace shows continuously updated information about the estimated arrival time of the driver, so you don't have to wait in the pickup location for a long time. So essentially, Go-Jek Marketplace is a combination of all these factors. This entire pipeline happens millions of times a day, and every efficient allocation counts. So you can consider a Go-Jek marketplace as a highly complex machinery that takes into consideration the ever-changing real world and acts accordingly to provide the best user experience possible for you. These are not just an exhaustive list of functions in the Go-Jek marketplace team, but these are some of the critical ones. Pre-dispatch function refers to any operation that happens before a customer makes a Go-Jek booking. And pricing is a complex machinery itself, where it involves a variation of pricing structures, and it takes into consideration the supply-demand situation in a given place at a given time and adapts accordingly. So dispatch or matchmaking is nothing but allocating the right drivers to the right customer. And driver incentive is a function that operates to keep the drivers incentivized to do the right behavior and keeps them motivated. Today specifically we'll be focusing on the dispatch and matchmaking problem at Go-Jek, and let's do a deep dive into it. So, what is matchmaking? Matchmaking is nothing but providing the best service provider for a given service seeker, which is our customer. In terms of ride hailing, this is just providing the best driver for the given job. This visualization is what we call the heart of Jakarta, and it's completely plotted using Go-Jek drivers' latitude and longitude information from their phones, and this not only beautifully shows the incoming and outflowing traffic in and out of the central business district of Jakarta over the period of one day, but it also highlights the magnitude of the task involved. There are millions and millions of transactions happening every day in Go-Jek, and especially for a two-wheeler ride booking or a four-wheeler ride booking, and this provides an enormous opportunity to optimize this and create a big impact for our entire operational efficiency of the marketplace. So why not just use the closest distance, closest driver for the allocation? Let's look at a few interesting scenarios to understand the situation. Imagine you are ordering a Go car from this specific building at AXA Tower, and there is a driver a couple of blocks away from you. The straight line distance, or what we call as a crow flight distance, is about 300 meters. But in reality, cars don't fly. So this is the route they took to arrive to the AXA Tower, and depending upon the traffic conditions, the time may vary between 3 minutes to 5 minutes and so on. So in this specific scenario, you could have chosen a driver who is far away but traveling in the Shenton Way road and coming towards AXA Tower. This is another interesting example. This is what we call as a Cloverleaf Junction, and these are very common in Indonesia. Let's assume that there's a customer here trying to make a go-car booking, and it finds a driver traveling in this specific direction. Even though the driver is close to the customer, in order for him to reach that specific pickup point, he has to make this complicated sequence of maneuvers and reach the pickup location. So these things are just highlighting the complications involved in making a particular match for customers and our riders. So why don't we assign the closest driver to you? These are some of the factors that we consider. So the traffic conditions in certain places are really volatile, and you have to take them into consideration when you're allocating drivers to customers. And the driver preferences, since Go-Jek is a multi-service type product, Go-Jek driver has an option to do a ride service or deliver food or any other choice. So certain drivers have certain preferences, and we would like to capture them during the allocation. Drivers may have favorite locations, like at the end of the day, if they want to go back to the home, they don't want to take a ride which leads them to the other end of the city. And customer might have their own preferences. Certain customers are much more patient and are okay to wait for a driver, but certain customers try to cancel the booking if they see that the drivers are too far. These are just a few examples, but there are much more to consider. So, two things I would like to highlight in this presentation is that the magnitude of the task involved and the number of factors to optimize gives a great potential to make it as a machine learning problem to solve, and that's what we did with Rank. Rank, or driver ranking system, is the first ML model to be deployed in Go-Jek and at scale. And like a first step, the model was a simple supervised machine learning model, and it has this familiar steps where we perform ETL based on the historical data stored and initiate a model training. Once the model is trained, we deploy the model as a web service for real-time inference. Looks all good. So although I have masked most of the technicalities involved in this pipeline, it was a pretty sophisticated system, and in the sense that we were able to achieve one-click deployment for the system, and the CI/CD pipelines were automatically integrated with load testing, functional testing components, and the model would trigger and train every day, validate the end result of the model training, and with the push of a single button deploy into production. So and we generally used more than 150 features to train the model. Some were location based, driver preferences, customer preferences, their behaviors, and so on. Okay, but the entire objective of the model was to improve the operational efficiency of allocation, and it just did one thing, and it did really well. Once the model was deployed, it was a huge success. It improved the operational efficiency significantly, and it also was recognized well with the business users. But what happened? Let's take a look at what happened later. At Go-Jek, business really changes fast. Things that work well at a given point of time become completely obsolete or useless in a matter of couple of months. So at the same point of time, Go-Jek started expanding to overseas markets outside Indonesia, like Singapore, Thailand, and Vietnam. And these specific geographies had different objectives and different behavior of drivers. This was a challenging task to accomplish for Rank, and the next biggest problem for Rank was to iterate fast and experiment faster. Most of the time, the offline metrics such as AUC or whatever score we use does not correlate very well or with the real world metrics that we compare to. And even simple situations like adding a single new feature would require enormous change, because the entire pipeline from ETL to model training and the web service has to be replaced, right? So the architecture of Rank did its job well, but it had all these tight couplings, and it made it really difficult to improve the model, test different modular components, and add new features or try other different variations of models. And respond to external behavior. Rank wasn't really designed to react fast to external behavior. It had a traditional pipeline in the sense that I trained on historical data, and what I tried to do was to just optimize a single objective. Some of the external behavior that changes fast, I can give an example of say drivers using fake GPS. The behavior of drivers, even when certain fraud teams try to capture the behavior changes very fast, and these sort of fraudsters do affect the network efficiency. GPS being spoofed to different location, and when you assign the driver to a specific customer, the real arrival times for those drivers are very long. And Rank was simply not designed to solve these types of problems. And we took this time and opportunity to think deeply about certain problems and areas of improvement that we could handle for Rank, and those are how we should formulate the problems, the feedback loops involved in training a machine learning model and then deploying it in real world production, and some of the manual overrides we wanted to achieve with it. In order to explain these things in detail, I would like to invite Peter to talk about how we converted these problems and addressed them well in Jaeger.
Thank you, Jared. So, Drank. So Jek was the history at Go-Jek, so I get the more fun job talking about what we're doing now, what the current state of the allocation system is. Yeah, Jared's already introduced Jaeger, so that's what we call our new allocation system. So what were the things that our main objectives, were the main reasons why we decided we needed to rebuild? I think Jared's already hinted at a few. We needed more flexibility. I think Drank was a very powerful tool. The model did a very good job at what it was intended to do, but it was a little bit like we had a rocket launcher which we were trying to fire blindfolded. You know, if we hit the target, there was a lot of luck involved. So this is kind of the also the reason for the name Jaeger. It's kind of wasn't my name, but it's kind of it refers to, I think it's a Pacific Rim reference. But it's a guy, something like this, a sort of interface of a human and a machine. So we're trying to get the best of machine learning, but keep a lot of flexibility for human intervention and to configure the business objectives. Manually override the model if we need to. We also needed it to be a lot more responsive. The allocation problem is very non-stationary. So we need to train, refresh the model very quickly. We need real-time features into the model. One thing that we've spent a lot of time thinking about is how we fare to drivers. We don't want to just, if one driver has a bad day, or just has one or two cancellations, we don't want them to be deprioritized for the next 2 weeks or something. So how do we make sure we're reactive enough so that we're fair to drivers that are performing well? We should be allocating them more rides. I think it's very. So we need to get more real-time features into the model. And then the next objective was to make it multi-objective, so going from one model to many models, each optimizing for different models. So why did we think this was so important? Well, partly as Jared has already said, the business is always changing. Often from week to week they flip-flop and say, no, we should optimize for this, no, we should optimize for this. If you just have one model, it's very difficult to do that. And also, as we've expanded, we've launched to Singapore, Thailand, Vietnam. These are very different places. We need to have a different model, different objectives. We also need to test different ways of framing the model. I think this is probably the main takeaway for me from building this, moving from Drank to Jaeger, is that when you have a supervised learning model, how you define your target is by an order of magnitude more important than anything else, I would say. Particularly if it's not a sort of cookie cutter, application of machine learning. If it's a sort of slightly bespoke solution, I guess. How you define the target, super important. So that means you can't just rely on offline metrics like AUC. If you have two different models that are predicting two different things, it's meaningless to compare those metrics. So you need to be able to test those online, and iterate very quickly. So that was a big driving factor for us to build Jaeger. Control feedback loops. Yeah, this is an interesting one. I think what we found with Drank was the performance initially was quite good, but then it kind of degraded over time. And what we found was once the model was sort of been refreshed on data that it had itself generated, we got these kind of amplifying effects, and there were some biases maybe in the model which were getting amplified, and it was degrading our performance. So we needed more control in order to address this. I think I think the reason for the bias, or a big reason for the bias, was that we only had one model, so we had a sort of monolithic prediction problem, I guess. And with Jaeger, we decided we need to break up this problem into smaller prediction problems with different models, and then we could control how we actually combine the outputs of those different models. So yeah, finally, similar point, but as we all know, if you ensemble multiple models, it often performs better than one model. So yeah, we wanted a way to experiment different ways to ensemble different models. So we've decided we need a lot of models because we've got multiple objectives now. We already have 18 plus products, many cities, and at any one time we'll have dozens of experiments, different versions of the models with different features, we're experimenting. So when we built Drank, one model, deployed it, and now we realized, okay, we actually need hundreds, maybe thousands of different models. How are we going to scale this up? We need to, for each model, we need to do the feature creation, the training, the deployment, the serving, the ensembling, and the experimentation. How do we manage this big, complex system? And I think I can't go into all the details of how we did that, but I'd just like to focus on probably the most important tool that we had, most important sort of abstraction to make this problem more tractable, is what we call the feature store, or feast. Okay, I'm going to give up on this. And good news for all of you is that we open sourced Feast a few weeks ago. So this is basically our system for it's on GitHub. Don't need to take pictures. So yeah, this basically it doesn't do the feature creation, but it does the feature storage. So it's a very useful abstraction we found, just obviously for sharing features between different models and for ensuring the consistency of features between training and production. I can't take any credit for Feast. It was built by the PS platform team here, and I probably can't answer any difficult questions, but I'm just one happy customer, so that's just the perspective I'm going to give you. So what did Feast allow us to do with Jaeger, in Jaeger? So this is more or less what we had in the old days with Drank. We just had one sort of monolithic pipeline, raw data, feature engineering, model training, then this would trigger the GitLab CI pipeline to deploy the model, and it would end up in production. Now we have one model. We want to go to hundreds, possibly thousands of models. We can't just multiply this 1,000 times. So this is more or less where we are today. We've broken up this pipeline at the bottom with the feature store. So generating the feature engineering, it could be batch, in Airflow, or it could be real-time streaming features in Blink or Apache Beam or something. So that happens as a separate process. It will ingest into the feature store, and then we can train the models, put in the data from Feast, then we can run that. We can do the model training in whatever tool we prefer, and then we have a sort of model store that's analogous to the feature store, using MLflow currently. And then for deployment, we found that GoCD was a better fit than GitLab CI. And then on the production side, we needed a system to integrate all of these models, to fetch features, obviously first, then call the models, then ensemble them. That's Meister, Jaeger Meister. So it does the ensembling and also the logic for the experimentation. And then in the center we have Lasso, which is a sort of orchestrated service, which is open source also, or soon to be open source. But I'm not going to go into the details of this because you'll hear from Jilling in a few minutes, and she'll be able to explain this much better than me. So yeah, you notice we have the feast at the top there, so that's where we need to serve, get the features in real time for each request, and then send them to each of the models asynchronously. So what Feast has allowed us to do, it's made it much easier to get real-time features into the model, because we don't have to worry about the inconsistencies between training and serving. It makes it easy and natural to share features. You define it once, it gets ingested in Feast, and then all of these models and other models, different projects, can use those features. And also an extension of this is that you can also have another model that is predicting something, maybe some driver levels fraud score, for instance. That can then be ingested into Feast as a feature, and then that's a feature for our models in allocation. So I think it's really helped improve the collaboration in the data science team. The guys that are building this driver fraud model, they might be in Jakarta, but we're in Singapore. Feast allows us to collaborate in a very productive way. Because we've broken up this pipeline at the bottom, each stage, we can choose the tools that make sense, and this has made it, this much more modular approach has made it much easier to scale to dozens and hundreds of models. And then finally, we found it's pretty performant. So this is the serving latency. This is when we first rolled out Feast for Jaeger. We were monitoring the latency of fetching these features, and as you can see, it kind of dropped off a cliff, which was very good news for us. We were having a lot of timeouts before. We moved to Feast. We solved that problem. I can't give you a good reason why we managed to achieve this, but kind of my point is, before this, part of the reason why this was so slow is that me and Jared, the data scientists, were manually loading features into a big table we were using. As a data scientist, you don't want to be doing that. So Feast gets the division of responsibilities correct, I think. So as a data scientist, I don't have to worry about the serving agency. I just get my features and I'm happy. So this all added up, I think it's had a lot of success, a lot of business impact. I would say the one biggest thing, most important thing, as I mentioned, is being able to try out different models, different framings of a problem in terms of different targets in a supervised learning model, and then quickly, easily put that into production, see the uplift. So yeah, we've got a lot of appreciation from the business, from our bosses, which is nice. I think obviously they care about the uplift in the metrics, but I think they also recognise that we've built to a robust system that is going to scale with the business, and as our needs change, we're not going to have to rebuild again. So yeah, that's it for me. I think we have time for a few questions now before we move on to Julian.
Yes, hi, thanks for the presentation. Just wondering, could you give an example of what the model actually outputs and a few examples of its inputs?
Yeah, so Gerard mentioned the main sort of features we have. They tend to be, driver level features, or customer level features, or the sort of the geo type features associated with that trip. They're the inputs. We have a lot. I can't go into all of them. The output, yeah, I mean, it just depends on what the business metric we're optimizing for is. So we have a lot of different models optimizing for different objectives. Yeah, I mean, obviously, the number of completed bookings, just converting the booking is a big one. But there's lots of other things like.
You want to reduce fake TPS or?
Yeah, we have fraud. It's been a big problem. Drivers, a lot of our drivers seem to like Pokemon Go a lot. They ghost their location for some reason. So trying to, obviously that is influencing the marketplace in a very bad way. So we tried very hard to deal with that quite successfully. Yeah, there's really, yeah, whatever the business says they care about this week, that's what the metric is.
Hi, thanks. I have a couple of questions. So before you were doing Drunk, you were saying that it improved your operations. What were you doing before? Like, what did it improve upon? That's the first question. The second one is, what breaks the most? What features break the model the most? Because you were saying that things change really fast. After a few months, things stop working. Well, which features are responsible?
It was just problem formulation. We were not looking at the right metric to optimize for. We thought that the acceptance rate of drivers is a good indication of our network efficiency. But really what happened later was that we found that in order to improve the network efficiency holistically, we have to look at different objectives and metrics and have certain constraints on them. So that is how we differentiated with Jaeger. Some of the examples of real-time changes are, like Peter mentioned in the talk, it's about driver behavior changes. Sometimes, if a driver is having a bad day because of, it might be an issue with his mobile phone or something where he is not able to accept proper orders. that might lead to poor driver statistics, and we don't want such things to get the drivers deprioritized.
Yeah, I think, as we mentioned, fraud is a big one that is always fast changing. It's always an arms race. I think we're in danger of overrunning already. So.
All right, thank you, Peter. Thank you, Joai. Everyone, please secure round of applause. Sorry, I had to cut the question short. We have 4 sharings and we're already halfway through, and it's already 8 p.m. Next, we have Ziling, who will be sharing about Lasso, about Go-Jek service orchestration.
Say again. Thank you everyone. I'm Ziling. So just like how I did ushering in front, and then I'm talking to you now, and I'm probably doing cleanup. I specialize in the end-to-end deployment of machine learning models. So my team does not only deployment of models, but also the building up of a platform for the data scientists to bring their models to production in as fast a manner as possible. Yeah. So today I'm going to talk to you about building complex machine learning workflows here at Go-Jek. Yeah. So I hope that sounds slightly exciting to you guys. Yeah. Thanks. Okay, so let's talk about model deployment, right? When you think about putting models into deployment, what is it that you think about? Sorry, I didn't find the mouse. Yeah. So you expect that with your model up somewhere in the cloud, you receive some sort of request, and then it will return some sort of response, right? And this would go through some sort of model. Something like this, right? So request into model and response. So a lot of serverless machine learning deployment solutions, they focus on this. You can deploy a model, and it focuses on outputting whatever the model, whatever the model outputs. So it's just in and out, right? But realistically, what you'll be having is something like this, right? You would have some sort of pre-processing of the request, and it goes to the model, and then the response would have to be post-processed before it's returned to whoever is querying the service. But it's not usually this simple, right? This is like, I don't know, maybe you built this in university or something, but this is hardly ever good enough, right? So a common pattern is that you would have some sort of features, right, in some DB somewhere. These would be batch features, and you retrieve this during the pre-processing stage, and these would be passed to the model, and then the response would be post-processed, and this would be returned to the person that's querying it. So this still looks pretty simple, pretty doable. You could do it in a really small microservice, but then it gets more complex. What if your model requires some sort of fallback logic? What if your model is something that's complex and could possibly take very long? So for instance, if let's say you had some sort of deep learning model that couldn't possibly return a response within 60 ms 99% of the time, right? What do you do with the responses that fail to be created on time? You need some sort of fallback logic, right? And this fallback logic would have to go inside your app. And then what if you have 2 models, right? What if you have 2 models and you want to do some sort of traffic splitting between the 2? This is actually a very common pattern. Let's say if you wanted to segment your population, you wanted population A to get results from a model that you are, a base model, and you want some test population to get results from a model that you are experimenting on, right? And then what if you had even more models, right? And it's not even traffic splitting this time. You want to ensemble them, right? You want your request to go to each of these models. You need to run some sort of post-processing step